Most electricians think cable tray is perforated so you can put cable ties through it. That's wrong. By the end of this video, you'll know the real reason and it will change how you think about every cable run you install. Today, we're taking a deep dive into cable tray, cable basket and cable ladder. What each one's actually for, where you'd use it, and the manufacturer's data that keeps you out of trouble. We're working with Marshall-Tufflex. Yes, the trunking people, but they do a complete metal containment range. One of the reasons cable tray has been so widely used is because of its versatility and that it can be supported in several different ways depending on the building and the application. In a corridor or plant room, you may find tray mounted directly to the wall using cantilever brackets. Above a suspended ceiling, it may be suspended from threaded rod using a trapeze arrangement. In industrial environments, it may be mounted directly to steelwork. And in most bougie coffee shops, you'll normally find it exposed for the whole world to see. The containment itself is only one part of the installation. The support system is equally important, and that's why we have to think about loading. When people first look at a cable tray datasheet, they tend to focus on the width. How many cables can I physically fit onto it? But manufacturers are more interested in something else: how much weight that tray can support. Let's take a 100mm medium duty tray as an example. If we look at the manufacturer's data, it has a published filling load of 5.3 kilograms per meter. At first glance, that doesn't sound like much, but what does it actually mean? Imagine we install 10 meters of that tray. The tray itself is now capable of supporting approximately 53 kilograms of cable load distributed along that length. Now let's put some real cables onto it. A typical 4-core 25mm squared steel wide armoured weighs somewhere around 1.9 kilograms per meter, depending on the manufacturer. If we install 2 of those cables, we've already used about 3.8 kilograms of our available 5.3 kilograms per meter. Add another one and we're at 5.7 kilograms per meter. We've exceeded the published filling load of that tray. Suddenly the loading figure starts to become very relevant. Now let's compare that with a heavy duty version of the same 100mm tray. The width hasn't changed, the tray is still 100mm wide, but the filling load increases to 11.3 kilograms per meter. The same tray width can now support almost twice the cable weight. That extra capacity comes from the changes to the profile of the tray itself. The side flanges are deeper and the construction is stronger, allowing it to resist bending under greater loads. But loading is only part of the story. The support spacings matter just as much. Imagine placing 2 ladders on the floor and laying a scaffold board between them. Move the ladders closer together and the board feels solid. Move them further apart and the board starts to flex. Cable tray behaves in exactly the same way. As the distance between the support increases, the bending force increases. The tray deflects more and the carrying capability reduces. This is why manufacturers publish load information alongside support recommendations. And when you start looking at larger installations carrying multiple submains, distribution circuits and large steel wired armoured cables, understanding those loading figures becomes essential rather than optional. What often catches people out is that the tray might not be the limiting factor at all. The bracket may reach its limits first, the threaded rod might reach its limit first, or the fixing anchoring everything back to the structure may become the weakest point in that installation. So when we talk about containment loading, we're really talking about the entire support system working together. Now while we're looking at the tray itself, there is another detail worth mentioning: the perforations. Most people assume those holes are there simply for cable ties, and while they are very handy for that purpose, that's not exactly why they exist. We'll come back to those a little later because their real purpose tells us quite a lot about how cable tray is engineered. You're on a job where the design changes every fortnight. Rooms move, services shift, and that's where basket wins. Not because it's stronger, but because it was engineered for exactly that chaos. Now at first glance, cable basket looks like a lighter version of cable tray. Both support cables, both can be mounted on walls, ceilings and steelwork. Both can be suspended on threaded rod or trapeze systems, and both are commonly found in commercial and industrial buildings. But basket was designed with a different objective in mind. Where tray evolved around providing a continuous support surface for cables, basket evolved around installation speed and flexibility. You can see that immediately in the construction. Rather than a solid perforated base, basket uses a welded steel wire structure. That open structure brings several advantages. The first is speed of installation. If you've ever worked with basket on site, you'll know that it can often be cut, shaped and modified without needing a large range of dedicated fixings. Changes in direction can frequently be formed directly from the basket itself. Drops into panels can be created on site. Tees and offsets can often be produced from a straight straight section. That flexibility in basket makes it particularly attractive in environments where layouts change regularly. Office fit-outs are a good example. The building may be reconfigured several times throughout its life. Departments move, new desks appear, additional data points are installed, security systems are upgraded. In those situations, the containment needs to be adaptable, and basket allows additional cables to be installed, removed, or rerouted with relatively little disruption. The open wire structure also makes visual inspection much easier. You can immediately see what is installed and where it is going. Ventilation around the cable is also improved because the cables are not sitting on a continuous steel base. That doesn't necessarily mean the cables will carry more current, as current carrying capacity is determined by several factors, but it does mean heat can dissipate more freely around the cable installation. Now, one assumption that is often made is that basket must be weaker than tray, but once we start looking at the manufacturer's data, things become more interesting. Just like tray, basket systems are designed and tested in accordance with recognized standards and are supplied with loading information and support span recommendations. If we take a typical 100mm wide by 65mm deep basket as an example, the published load carrying capability changes significantly depending on the support spacing. At support centers of approximately 1 meter, the basket can support close to 90 kilograms per meter. Increase the support spacings towards 2 meters and that figure falls to around 30 kilograms per meter. The basket hasn't changed, the steel hasn't changed, the width hasn't changed. The only thing that has changed is that distance between the supports. This illustrates an important point that applies to all containment systems. The loading figure and the support span are linked together. This is why manufacturers publish graphs and loading tables rather than a single headline figure. But they do highlight an important fact. Basket is not simply a lightweight alternative to tray. It is a fully engineered containment system with its own design criteria. Where basket can begin to lose ground is where we start introducing large quantities of heavy power cables, multiple steel-wired armoured submains, large distribution circuits, industrial power installations.
I have a theory. Every electrician in Britain has fitted Marshall-Tufflex trunking. Not most electricians, all of them. It's impossible not to. I reckon it's built into the qualification.
Name? Joe. Qualifications? Level 3.
Have you ever fitted Marshall-Tufflex mini trunking?
Yes.
Look, this stuff is everywhere. Schools, hospitals, offices, International Space Station. So how did I feel when I found out they made more than trunking? They've got tray, basket, ladder, GRP system. At which point you realise you've accidentally spent the last 10 years thinking of them as the trunking people. We were wrong. They are so much more and well worth checking out.
Cable ladder is where containment starts to become a structural support system rather than simply a method of routing cables. If you walk through a modern office building, you'll often find basket carrying data cabling and small power circuits because flexibility and future modifications are usually the priority. Walk through a factory, a data center, a power station, or a large industrial installation, and the priorities start to change. The cable size increases, the cable weights increase, the distances increase. And very quickly, the challenge becomes one of supporting substantial loads safely over long spans. That's exactly why ladder was developed. The easiest way to understand the difference is to look at the support distances. When we discussed basket, we were looking at support centers typically around 1 to 2 meters apart. With ladder, those distances become much larger. If we take a typical ladder with a 125mm side rail, it can support 223 kilograms per meter with support centers spaced 4.3 meters apart. Increase the side rail height to 150 millimeters and that rises to 296 kilograms per meter. Think about what that actually means. A 10-meter run of ladder could be supporting well over 2 tons of cable load while only requiring support points every 4 meters. That is a completely different engineering problem from supporting a handful of circuits above a suspended ceiling. Unlike tray, which spreads materials across the base, ladder concentrates its strength into the side rails. Those side rails do most of the structural work, while the rungs support the cable at regular intervals. The result is a containment system that is both strong and relatively efficient in terms of material usage. Another benefit is ventilation. The open rung design allows air to circulate freely around the cable, and that becomes increasingly useful as cable sizes and currents increase because larger cables inevitably generate more heat. But by now you do know the drill. Loading and span are married. What changes on ladder is the scale of the consequence when you get it wrong. The brackets, steelwork, threaded rod and fixings all become part of that design calculation. If any one of those those components is undersized, it can become the limiting factor regardless of how strong the ladder itself might be. The environment also starts to become more important as installations become larger and more exposed. A ladder installed inside a dry building may perform perfectly well with a pre-galvanized finish, but place that same containment outside on a factory roof and the situation changes considerably. The containment is now exposed to rain, condensation, temperature cycling and airborne contaminants for decades. This is why manufacturers offer different finishes and materials. Hot dip galvanized systems provide a much thicker protective coating for external installations, while stainless steel and GRP systems become attractive where corrosion resistance becomes a primary design consideration. And this really brings us back to the central theme of this whole video. Tray, basket and ladder are not competing products. They are different engineering solutions designed around different installation requirements. But before we finish, let's get back to those holes. Are they really there for your cable ties? Well, yes and no. You can absolutely use them for cable ties. You can use them for fixing accessories, but that isn't why they exist. The perforations are actually part of the engineering of the tray itself. They reduce the amount of material required to manufacture the containment while maintaining much of its structural performance. They reduce weight, making the tray easier to transport and install. They improve ventilation around the cables, and they allow water to drain rather than collecting within the containment. And if you'd like to see that thinking put into practice, including a real-world GRP containment installation we carried out at Skipton, then click the video on screen now.